Thank you all very much for coming here today. My name is Ran, and in the following session, I'm going to talk about what we should all worry when monitoring serverless application. We discussed a lot about security and deployment and testing and so on, but monitoring is a crucial part in production application. And in case you wondered, the developers, us, should worry the most when talking about monitoring, and I'll elaborate. So we wake up one morning and we say, oh my God, Lambda or functions, it's so cool. I really need to do it. Like it's zero configuration, almost zero configuration. It's easier to deploy. I don't need to do anything in terms of scaling. So I come to my executive, as we all do, and say, let's do serverless. At this point, do you know what's going on their mind? Or what do they think about you? So I actually had that moment captured. It looked roughly like this. Disaster, complete disaster. What's going to be in production? Everything is going to be a disaster. And the main question is why? Why? Because it's different. And understand what processes are running and see all the logs and be able to stop everything and restart everything. But nowadays we can't do it. We don't have any server that we can connect to and do some debugging. Also the environment has changed. We can't anymore run with unlimited amount of memory. We can't run with an unlimited amount of time. As the previous guys discussed, we have a limited amount of resources. And also the code or the way we develop software has changed as well. We used to have this big monolithic application we deploy on a server with all our dependencies and requirements, and now our code is being fragmented, highly distributed, lots of small components, and it's also event-driven. It means that it's not the same wild true code that's running forever, but other than that is event-driven. So on top of that, we would still like to be able to monitor. We still need to monitor our applications in production, and it's for three main reasons. First of all, we need to track and see the system health, that everything is going on correctly and properly as we should. The second part will be to troubleshoot and fix. Well, the last thing we would like as developers to do is to wake up at 4 a.m. in the morning and understand that something broke, and then start to redeploy the function, add some prints, roll back to the different version, and try to understand what led to this issue. We want to be able to pinpoint the issue quickly and efficiently as possible, and to be able to fix everything as soon as possible. And the last part is to be able to optimize our application. We have plenty of flaws in our application. We need to be able to make it better. If we have a user registration, we need it to take as fast as possible. And also cost. Cost is varying from one application to another in serverless. It all depends on the use that we're using. So after this introduction, let me introduce myself. My name is Ribenzaft. I'm the co-founder and CTO at Epsagon. Now it would be a perfect time for you to take a picture of me and upload it to Twitter. I promise that the best picture will be my next cover photo. In my previous roles, I've been lots of years in the IDF doing R&D and cybersecurity. I also, in one of my scenes, developed some Alexa skills for my own personal use. And I'm an AWS developer for several years as well, so I'm pretty familiar with what's going on. So let's talk about the new challenges of serverless. We talked about security and testing and so on, but let's talk specifically in terms of understanding what's going on, or be able to understand our new environment. So I said there are a limited amount of compute resources. In general, it's true, but here the limits are hard limits. When we set a new function, we decide how much memory do we want to use for that function. If we cross that, we're doomed. The function is dead, and some user experienced it, and it's bad. We also have a limited amount of running time. It means that if our code runs for more than 5 minutes, the code breaks, and again, we're doomed. The user experienced it. And the last thing is that our code is stateless now. It means that we have to use other resources to save the state, as the previous guy said, databases or storages or any other queues to pass message from one resource to another. So it's definitely new challenges. And all these challenges lead us to design software differently. And it's composed with lots of functions and much more smaller functions. In functions, I'm saying in general, it's same for microservices. We have lots of components. Each one is doing a simple role. other than the way we used to do with monoliths. And now, in order to overcome the stateless issue, we utilize external resources or APIs. For example, if you want to store messages or store data, we can use databases, message queues, storages, and so on. We also use external APIs such as Auth0, Slack, Stripe, and so on. This is what we get when we build a real serverless application. It's just like this library when you end up with hundreds of functions, hundreds of resources, and you need to look up, wait, what broke here and what led to it, and okay, let me look for it in here, and it becomes a real mess, and we need to understand what's going on. Other than that, the metrics that we use to look when we're monitoring has changed as well. If we used to have this VM or server and we wanted to understand the network bandwidth or the CPU usage or the free storage, all these are obsolete nowadays. The things that are really matter in serverless are flows, understand what kind of resources are interacting with each other, or timeouts. We need to understand when we are close to timeout or when our user experience timeout. Cold start, obviously, which is a phenomena that started to happen in serverless, out of memory as well, and definitely errors and latency that remain throughout the years. But here we still need to understand them, and it's a bit different, and I'll talk about them. Without the right tools, we'll end up like this, and now I'm going to discuss about some use cases. I'll start with the first one, troubleshooting errors. It's the pain point of every developer in every state, in every company, anywhere in the world. So we have this kind of application. Let me introduce you, Jan. Jan is also going to present here next. Thank you for coming from London. And in one of his previous roles, jobs, he used to develop and migrate existing application to serverless. As you see, this serverless application composed with Lambda functions, but also SNS and API gateways and Kinesis stream and so on. This is not as that complex application, but let's imagine when we have an issue in this Lambda over here. So first of all, we will never know as developers that something had happened because no one tells us that the code breaks because it's still running. We don't have to manage it. So we need to understand what happened, and if we're that curious developer that went into the second part of the AWS management and saw that someday, 2 days ago, there was an issue or error and something bad happened, so it's okay, we decide to jump in and start to look for the logs and understand what happened. And just out of curiosity, who is familiar with that screen? Yeah, great. So that screen is part of the CloudWatch. In case you are the curious developer that wanted to really troubleshoot this issue, you end up in the screen with endless rows of logs. And it's actually not the logs themselves, it's only groups of logs. So you need to identify in which group your log is existing. So you end up after a few hours, and selecting one, and then you still end up with hundreds or thousands of extra logs that you still need to find where your error is located in, which really sucks. And it might take us like, I don't know, 5 hours just to understand what's going on. And in the meantime, there's a downtime, and our boss is on our back. Hey, put it back, I want to understand what's going on. And even if you find it, you still need to understand what happened before that. I mean, the perfect thing that we would be able to do is to trace back the originating of this issue, which can be even longer than this. This is only a second hop from the Lambda itself. And imagine when you end up with this kind of application. This is actually the full application that Jan has migrated, composed with 170 Lambda functions. It's really hard to understand what's going on. So I don't want to be that developer that wakes up in 4 a.m. in the morning and see what's going on. Let's talk about the way it should be. So first of all, we need to get the alert. I mean, we need to be able to get notified, whether it's by an email or Slack or webhook or any other kind of method that tells us, hey, you had an issue and this is the error, and be able to take us to the most interesting part, which is the flow, or what led us to this error. And in this case, we're seeing some other example, like a simple blog site that we've built on Epsagon. And you can understand what led to another, even without talking to you, understand there is an API gateway, it's a web server, and it triggered the Lambda, it sends a message, it uses external resources, and we instantly identify where the issue is, which is very easy, but then we want to understand what is the exception. And here we don't want to query tons of CloudWatch logs. We want to be able to understand what is the issue and get the traceback, whether it's Python or any other language, and also get the corresponding CloudWatch log in a matter of clicks and not like trying to look for endless rows. So this is the CloudWatch log that the user got. And other than that, we would like to be able to trace back. This is like the key thing in here. Trace back, even if it's asynchronous, even if it went through a message queue, we want to be able to understand what message went through that message queue. In this case, this was the message that went through between the Lambdas. And also, we would like to understand in the previous Lambdas what happened, or in the API gateway, what headers went in and which user initiated the whole process, or even external resources. We want to understand what was the interaction between them. We want to understand the whole flow. And this is what we can get, this is what we should get. The second use case is optimizing latency and cost. So in serverless, or in general, time is money. And it's a fact, it's a known fact for everyone, but in serverless, actually time is money. We paid by the millisecond in an interval of 100 milliseconds, but we pay for every millisecond that we're running. And we need to be able to understand how do we spend our time, or where do we spend our time in our application. In that case, we would like to understand what flows there are in our application. In this case, we're seeing the same blog site, but a different flow, not the same user is logging, but someone is uploading a post. And we can see, if I click to zoom in, we can see that in this part where I'm using an external resource, it takes almost 700 milliseconds to get request and response from Auth0, which, if we can take a look before that, all the rest of them are taking less than 100 milliseconds. So we want to be able to detect this kind of bottlenecks. And in this case, I'm talking about understand what kind of flows that I have, whether it's user registration, or user buying something, or any activity that the user is doing. And we want to be able to list and understand what are the bottlenecks, or what is taking the most in this kind of flows. I want to be able to optimize it. So one optimization could be switch from Auth0 to a different API, or trying to move from one region to another. It could be a lot of solutions, but we need to understand it. The last one would be to detect serverless specific issues. So you're very much familiar with all the traditional APMs that are offering you charts from end to end, like a nice screen that sits on the executive's room, all these charts, it all looks so cool, but for us it doesn't say anything. We want to be able to pinpoint something specific for serverless. And specific, I mean like how many invocations there were for each function, how many of them were errored, or how many of them were timeouted, and also understand our memory usage, if we're close to the amount of memory that our Lambda can get, or our function can get, and also the amount of duration that our code can run. If we're getting closer, we need to optimize our code, or maybe split it. All these things are really important because we're dealing with functions and not servers that can run forever or use unlimited amount of memory. Let's talk a bit about solutions in this area. So the first part, or the first thing we've encountered, that once you're doing Lambda, so you're doing another Lambda and another Lambda, and you end up with hundreds of Lambda functions. And it's really hard to understand where is everybody. Like, who set up this Lambda, and when was the last runtime for that Lambda? So we built some sort of a utility, and we shared it on the open source, as you can see on the link. It enumerates all your Lambda functions from all regions and tells you when was the last invocation for that Lambda. This is mainly used to detect and remove dead Lambda functions. We built it on top of AWS CLI, but in AWS CLI, you need to look for every region. And you also, if you have more than 50 per region, you need to paginate. So it's a basic utility. You put your credentials or use the existing credentials in your machine, and generates also a CSV with lots of data, the description, and other parts that the Lambda has. The other one is to get alerts when something bad happens, and specifically in AWS it's called dead letter queues. It allows us to understand what event led to the death of the Lambda. And with a simple configuration, I'm just telling you the idea, there are lots of tutorials out there how to do it. With a simple configuration, we can set the Lambda that once it is dying incorrectly, it will send a message to SNS. SNS will send an email to the email addresses that you would like. So at least you would be aware when there is an issue and be able to fix it. And the last part, actually this is the most fun part, bring your own log. As we saw, CloudWatch is not a great utility for debugging or looking for bad things. So there's also plenty of tutorials on setting CloudTrail. CloudTrail is following every invocation of your Lambda. And there's a simple configuration that you can stream all data to S3, and with ELK stack, Elasticsearch, Logstash, and Kibana, you can get everything from S3, and then you'll be able to seek through errors or seek through the data much more easily. So that's it. As I said, I'm Ran from Epsagon. We're building cool stuff. If you're looking for extra information, our booth is over there. And thank you. Did it quickly, so we have a few minutes for questions. Yes. So it will show it. It wouldn't alert things that are related for security now. We're focusing on troubleshooting and performance monitoring. But it's something that you would be able to see that there was a request to a third-party API, and it's, yeah, but it's on you to understand, okay, don't know this third-party API, I'll investigate it. Any more questions? Yes. Yeah, so the question was, I'll try to define the question a bit differently. How do we track the flow and we understand what thing led to another? So in Epsagon, we do it by instrumentation. We're sitting on your code as part of an extra library, and we automatically understand what are you interacting with and understand all the data that go through one point to another. And then we're able to show you in this graph, this message went from here to there. We can cross asynchronous events, for example, going from Lambda to SNS to a different Lambda. So that's how we build it. Thank you, guys.